Hello everyone, today I want to tell you a short story about my home lab. I already told I made a few videos how I get it, how technical it looks like. I already made some modifications to it, so I'll show it in a minute. And what I want to tell you today, that's the second part. When you think that you have a perfect hardware for your home, which suits you for every task you want, you need actually. Yeah, so the second step is the software. And it's a pretty interesting step. It's pretty hard to find the best software, which could be not expensive, could fulfill all your needs, could be easily monitorable, you could do a backups of it, you could easily configure and understand it. Yes, and for these reasons I chose one of a few open source, free, and with a really big history systems, that is trueNAS. So let's go to my home office and continue the talk. So this is it. This is my working bench, as I already showed and talked about it. Finally I just made a few modifications. So one of these, that in this server I have mirrored two drives which are mirrored for most important data, and one drive was for the volatile data which I could easily replace, and I thought that I will do another same disk. I will put the same disk here to have a mirror between them. But in the end I understood that I have security here, I have volatile data here, and I have empty space, and it could be used for my system boot drive. And that was a good decision, because I can get rid of not very stable external USB drive. So by this reason by this decision I have less cables on my desktop. So this is how it looks now from the back. So it's only two cables now. I also removed the external USB 2.5 gigabit Ethernet card, because it's also additional cables and additional point of failure. But now I have, as it is before, now I'm using one of the 4 ports of gigabit card, and I already put in a 10 gigabit card. I don't use it at the moment. It's an amazing card, it's official HP supported card, but I don't use it at the moment because it heats up a lot, and then ventilator powers up a lot, and there's a lot of noise. Of course, it's different room and it doesn't matter in the end, but I don't need that speed at the moment, and if the case for me appears, I will use it. So it's here. And this port is for accessing this computer virtual monitor from everywhere over network. So that's for BIOS configuration, firmware updates, and just for a console. The switch which is here, it's 2.5 gigabits Netgear switch. So I use it mostly now because these two cables are creating a 1 gigabit connection, because they are connected to 1 gigabit card here. But I have 2.5 speed internet, so this is mostly to transfer that speed to my Mac Studio, which is here. This is my backup disk here, so it gets the data, the most important data I have from these two mirror drives. And the interesting thing I also configured, so the data from Mac Studio is automatically backed here, because I created a SAMBA here which supports the machine of macOS, So I also have my Mac Studio backups here, and the most important data is mirrored. And by using synchronization, once a week, all these backups come here automatically. I will talk about that. I configured that with AirSync. It's a pretty interesting topic. And yes, so this is that amazing, beautiful trueNAS system working here. Yeah, you can see that there's 32 gigs of RAM in it. So more RAM is coming, and I'm planning to have 64 gigabits because it's gigabytes because it's very important for the FS file system to have as much RAM as possible. So here we are. This is my trueNAS system monitoring screen, and we could go through it and see what I have here. And this configuration which I have here is a perfect setup for my home and for all my needs. I already don't have more ideas how to change or configure it because it completely suits my needs. It creates data safety for my personal files. It serves me files I need over the Ethernet, my home Ethernet, and that was the goal I wanted to reach with that system, and it suits for that perfectly. Alright, so let's go and see what I have. So this server, this HP ProLiant micro server, 10th generation, version plus version 2. So this is the official name of the HP, which includes the line and modifications which we made on this server. Is the latest one micro server. As you can see, it has Xeon CPU with 4 cores. It's pretty fast. It's more than enough for this situation. It's almost not used here. Already sharing the data, and for sharing, it's almost this system almost don't use processing power. Yeah, the next thing what I have on this server, as you can see, this is a 31 gigabyte of ECC memory. That was the most important topic for me because without that, because of cosmic rays, you can have data change in the RAM, and without the SSC it couldn't be noticed by the system and written down to the disks, and eventually system crash could happen, data could be damaged, and I can't afford that on my most important data. So the most important thing for me was to have a system which has ECC memory. So, and here is on the this in the memory how it is splitted. We have it allocated just a few gigabytes of memory for operating system, and it's more or less enough. Then all other space, now this is the blue space, it's free, but when you are sharing files via the first thing what the FS file system does, it puts these files into the memory and cache them, and in that situation the FS cache use 30 gigs of RAM. I made a configuration to have that and to use as much as possible RAM from caching. And because of that, when you connect to the server, you mostly working with a cache and with a memory disk, and this enables you to saturate 1 gigabit Ethernet I use here fully, and that speed is more than enough for me. So here we are. The third thing, you can see that my server is connected to the Ethernet by 1 gigabit link. And yeah, I had some data transfer today in the morning. Yeah, the fourth thing here in the monitor, you can see that I have two data pools. Data pool which is named data 4 terabytes. There are 2 mirror drives, and you can see from the configuration here that there are 2 disks, but we create one 4 terabyte data pool. This is the official name. It's online, only 3% of space is used because my main files were small, they usually text or small video files. They don't take a lot of space, but the most important thing, they should be saved safely. Then I have another pool, which is a media pool. That means that here is a volatile data. For example, I film with a drone, I have a lot of video files, these temporary files, we go here, and when I create a video, which should be held permanently, more or less, it comes here. As you can see, this is a 16 terabyte drive, which is filled by 4% already, so some space is taken by the file system. It's a one disk, it's not mirrored, so it's not very safe. But the same disk itself is Western Digital Gold, 16 terabyte, it's filled with helium. Have I think 1/2 of gigabyte cache, so it's fast, it's very safe, it's silent, so it's still a very great drive, and I'm happy to have it here. So the fifth tab is just same information about my Ethernet card, and this part is mostly useful for me just sometimes to push a button and see if there are some updates for the trueNAS system. Yeah, so if we come back, you can see that we have this small icon here, which routes us to the graphs for more detailed information and monitoring the system. So we will go to these graphs a little bit later. So going by the menus on the left, so let's go and to see what we have next. So coming from a dashboard, the next menu is the storage dashboard, and the nice thing is here, as nice thing with every screen here, that everything is very compact. So you just, if you look at the screen and you see that these green, you have in my case 8 green icons here, 8 green check marks. My system is working perfectly because every check is automated. It is made periodically, and my system is healthy and it works perfectly. And that's so you will take just 1 second to see that the system is perfect and healthy. I love that very much. And let's go through the details in this screen. So what we can see here, so for every pool you have topology. That means how it is constructed. So my pools are pretty simple. Data pool has 2 mirror drives, media pool has 1 drive, and that's it. Then you can see, you can have more disks for caching and for mostly for caching and speeding up the pool. But in my case, in my situation, and I think in most of the homes, you don't need always caching, so I don't use it. The second thing, you can see how much of your drives are used, so not a lot at the moment. The usage, I think, will grow up, but mostly for the media. Yeah, the third thing is the file system, the FS file system health monitoring part. Yes, the amazing thing about this file system is that it's self-healing file system. It does a lot of things to self-heal, And this is why I chose the trueNAS and this file system. And at the moment, I just don't know that there is a better file system for that. So what's interesting in this tab? So interesting things is that you can see that there are some scheduled self-healing tasks. So the scrub task, for example, scrub tasks, and what these tasks are doing. So every 7 days on Sunday at midnight, automatically this task is run up, and ZFS file system, it goes through every block of the data, calculates the checksum and compares it with the checksum which was calculated and saved when the data was written on the disk. So by this operations, it can check if every part of the data on the disk is correct, not modified, and is healthy as it was written. So by doing this task pretty often, so once a week it's pretty often, you can completely see the problems which will start appearing in the disk, and just swap the disk in the mirror. It will be repopulated, mirrored, and all the data will be completely safe. Because these are hard drives in a mirror, so I don't need a trim, so it is off. And you can see that when last scan was done, there was no errors at all found on the scan, and it took 18 minutes, not so much for scanning all the disk. So that's amazing, that's additional data safety. And of course, I monitor disk health here. So disk health is, you can understand disk health by a few parameters. So are the disks hot? So they are not hot at all. My CPU cooler, which cools also the case, it runs only at about 10%, and disks are at this temperature, 38 degrees of Celsius. So my server is quiet, disks are pretty cool, and I'm happy with that. Also, what's interesting here, I have periodic S.M.A.R.T tests. You can, I'll show how I configured them later on, but there are small, short tests which I do, as I remember, once a week, I think. We will check that. So it will take only a few minutes and go through all the parameters which disk itself can check. And once a month I have long S.M.A.R.T tests, which also check the full disk, and the reports are more detailed. So as you can see, there are also no failed tests here. And of course, if you add additional disks, there's a button here, you can add it to a pool, the button appears here. If we want to disconnect a disk and just place it into another server, or just save it in your closet, so you press this export disconnect button, and you can get a little bit more information by pressing the button on manage the disks. And here you can see the list of my disks. So to mirror disks, media disk, and startup disk. And here is the pool names. So let's go back again. Yeah, I forgot to mention that for the fast health you can start scrub manually here. Yes, you can manage data sets by pressing this button. So we will go here a little bit later. Then for managing the devices, you just press this button, which is on the topology tab, and you can see that in this mirror drive pool I have mirror disks which are online. These are the two mirror disks without an errors. So that's a really amazing overview of the disks I have here, of the file systems which run on these disks, how much these disks are used, and are they healthy. Alright, so when the in this screen, when the disk pools are created, which are an abstraction over the disk, so this is the abstraction layer. So when you create a data pools, you are like abstracting from the hardware, and further on the system you work with data pools only. So what is interesting later on, that you have two data pools, not the three disks as I have here, even four disks if you talk about the boot pool. But in the end here I have two data pools, like data pool and media data pool. And then you can create a data sets, numerous data sets on these data pools. So we can see here that once again I have two data pools, and inside of them I have two data sets. So let's see how data for terabytes data set looks like. So this is the information about it, that it has its file system type, it has some of the compression algorithm used on it to save some space, still have some speed. So LZ4 compression algorithm is pretty good for that. Then there is a path on the drive actually where this data set is situated. Here you can see what data protection is created on that data set. So actually you can see there is one rsync task. So this data set is once in a week it's mirrored to my backup drive, which I showed before. And of course, you can see that this data set is shared via Samba share, which is also accessible via the accessible for the time machine from the Mac Studio. So Mac Studio backups come here, and it's also accessible over Ethernet. Yeah. Let's see how media dataset looks. So you can see almost the same information here as it was before. The only thing is that there is no synchronization task, so I'm not backing up this dataset and the data which is on this 16 terabytes drive. Alright, so that's the basics of information you can see here, but it's also very good overview. So you can see your data sets. So I have three data sets here. All of them are shared, so accessible over the Ethernet, and one of them is and few of them are also backed up, and you can see by which tasks. Yeah, I also forget to mention that I'm creating a snapshot here of my data for terabytes dataset. Snapshot means that there is like a photo of the data at that moment, and you can do rollbacks later on if something bad happened with your data, so you can roll back to the previous state. So I'm doing so my snapshots are saved for 2 weeks. They are done, I think, once a day. We will check that later on. And I just can restore the state of the data if I damage something. So this is also amazing stuff. All right, so let's go further on. In the next screen, you can see that in this screen you can manage the services for sharing the data. So for usual home, I think Samba Share is more than enough because it's supported by Linux operating system, it's supported by Windows, it's supported by Mac OS. So all major operating systems are supported. And as you can see here, these are the free shares. My media is shared over the Ethernet, my data is shared over the Ethernet, and one of the data sets for Mac Studio Time Machine is also shared to be accessible, and Mac Studio saves backups here. Let's go to the most maybe interesting part of the trueNAS, that is a data protection screen, and this is where I spent a little bit more time to understand and configure it. So the first thing which is very important here in the data protection are the scrub tasks. And these scrub tasks are the tasks which checks every cluster on the disk with a checksum which was created when writing the data, and it is done every 7 days, and just a lot of time before the disk will crash, where here I can see an errors by the scrub tasks, and I could buy a new disk and just change it, and it will be mirrored and data will be restored. So these two tasks are essential for the data security. Then, as I mentioned already, I create periodic snapshots. So they are created every day and they are kept for 2 weeks. So every day I could restore the data state which was 1 day before. That's also amazing. So I have two data safety mechanisms, but that's not enough. Here at the bottom you can see automatic S.M.A.R.T tests. These tests are done by hard drives themselves, only they are initiated from the computer, and short tests they took only a few minutes, and I'm doing them every day. So every day I know that my hardware is perfect state, my disks are in the perfect state, and every month I am doing long tests, so check the full drives for long S.M.A.R.T tests, which is also additional more deep information about their health. So by having these three things like scrub tasks, periodic snapshots, and S.M.A.R.T tests, I already have a huge amount of data safety. I could prevent data failures just a lot of time before, just be ready for that. And the final step, which is very important here, is the backups of the data. You can backup with a trueNAS, you can backup data to a cloud, but that doesn't make a lot of sense for me, because by having this server at my home, I wanted to save money which I am spending on the backups on the cloud, and to have the safe backups at home. So actually I don't use it because that was the purpose. What I'm actually do, I created a rsync task. I think I would have additional video on that because it's pretty amazing topic. But Unix-like systems, they have a program which could also be run as a service, which copies data over network, and it has very small overhead, so it copying data very fast. I initiate the copy from my server with a client rsync program, which starts the copying, and the same program runs on my Mac Studio as a service. So I will have additional video on that, how to configure it. It runs all the time, and this copying is pretty fast. It's on the background, and I have every week I have a full backup of my most important data on additional disk. So at the moment of every part of my important data, it's mirrored in the data pool, which has 2 hard drives. It is scrubbed every week. I have data snapshots, I have S.M.A.R.T tests, and it's backed to an additional drive. So it's pretty safe. Alright, so as I mentioned, this is the most important screen, I think, in this system, and the most important tasks in the system. So about the synchronization, I will have additional video. I think it's amazing, important, and nice part of this system that it supports async. And let's go further. So another tab we have in this system is the network tab. What's interesting is here, and that was interesting discovery for me also. So yeah, I have very good 1 gigabit card with 4 ports on my server, and as you can see, the first IP address differs a lot from others. So the interesting thing is here that only one port is allowed to be one Ethernet card port is allowed to get IP address automatically from a DHCP server, and that's a pretty important thing, that every port should be in a different subnet. This is not only important for the data collisions if we will be in the same subnet, and you even technically can't enable DHCP here. If I press save, I'll get error because only one interface could be used for DHCP. And the other thing, that when you have 4 ports and you have all of them in different subnets, subnet is the second number in the IP address. You can see it differs on every interface. Then you can use, if you have all four ports on different subnets, you can you can aggregate them with Samba share, and aggregate the data through output through them. And for example, instead of 1 gigabit speed, have 4 gigabit speed here by using all of these interfaces together. So I don't use that because 1 gigabit is more than enough for me. The only thing which I done here, so I maximized the MTU figure. MTU is the size of the packet which is sent over Ethernet. So because I have a really good Ethernet card in this server, it supports the size of 9000, and in that case you maximize the through output of your Ethernet card, because you have jumbo frames, the bigger packets over the Ethernet, and then you have less overhead. So then you have like 5 or 6 packets instead of 1 packet, and you almost utilize the full bandwidth for the data transfer over Ethernet. So these are 2 things. So first thing, that you have I manually set these IP addresses actually here. You have separate, every interface you have on a separate subnet, and I set it manually. Only the first interface gets the automatical IP address from DHCP server. That's important because when the server is up, then you can automatically connect it through the local DNS name. And the other thing that for a faster transfer of big files, I I changed the MTU value from the default 1500 to 9000, and that's speed up by, I think, at least close to 10 megabytes per second speed on my Ethernet transfers. Alright, so this is, I think, all the information which is important on one screen. Let's go to the credentials. So on this screen you can configure the users. So for my configuration I was needing a few users here. That's for Plex share and another user for other shares. I'm using for my data shares. So it's pretty easy to configure with users. You have templates and for creating a new user, for example, all you need is a username, password, and that's it. And you just use some suggestions here and that's it. So it's pretty comfortable user interface for creating a user and for giving access to it. I don't think there is a need to talk about it more. It's not the most interesting part and it's pretty understandable, so let's go further. The other thing which trueNAS have, but actually I didn't had any use case for myself, yeah, but people have, so you can run virtual machines here. For that, of course, you need more memory. It could be enough 32 gigabytes, which I have here, but I think that you need more for that. And on the virtual machines, for example, you can run Windows here, so you can run our software on Windows and have the services over the Ethernet too. But for myself, I don't see any use cases for virtual machines. And the golden rule is that at first you should try to run the native application on the server. Then you could use Docker because it has additional overhead, but not very big, because Docker usually runs in the RAM. And only in the third case you run virtual machines. So I don't need that. The other interesting thing which trueNAS has is the applications. Applications are the actual applications packaged in the Docker components, and yeah, we could see what applications we have here. It's about 100 applications which you can find in this app store. So these are the prepared Docker components, Docker containers. Sorry, that's a wrong word. These are Docker containers, and you just, for example, there is a Home Assistant. You just set up the pool on which to install it and install it. And when this Docker component runs automatically when your server starts, and you can disable or stop the application, disable that container or enable it, and it also gives you additional services over the Ethernet as on the virtual machines. So So let's see what we have here, what applications we have here. So some interesting applications. There's a Plex server, for example. So you can also install it on the trueNAS server. I didn't install it here because it's on my Mac Studio. So Plex server on Mac Studio connects to my NAS server. And I've done that because it is much more powerful hardware on my Mac Studio for working with the video files, for transcoding mostly, or for analyzing video files. So my idea was that file server just doing one thing, sells the files, and tasks with the data should be done with more powerful and exactly for that application prepared hardware, and Mac Studio is perfect for that. So I don't have it, but I also tried that on trueNAS, on my trueNAS, and if you don't need a transcoding, and I usually don't need that because I transcode files for my clients, for the Apple TV myself. That gives me a much better user experience because you can search through a file much faster. It starts faster, it works fluently, you can scroll through a file much faster. So for me it's much better user experience to do transcoding once and then just serve the file. But in case if transcoding offline transcoding didn't went very well, Mac Studio kicks in and you done transcoding online and it works perfectly. So this setup for me looks perfectly. So if one of these computers are down, for example Mac Studio with Plex server is down, my network share is still working. So it's additional security layer to have hardware connected on the Ethernet, but not working, everything is working on the same server. And if we go back here, there's tons of applications, like much more applications are here. And yeah, as you can see, some interesting applications that you, for example, could have hard drive, Chia coin mining here. I was doing that before. It's pretty interesting and you can get some profit of that if you have enough disks and have enough plots created. So that's a pretty daunting task. It takes a lot of time and resources, but still. Other interesting stuff you can have here, it's Nextcloud, so you can share your drives over the internet. You can offer a cloud services. It's pretty amazing service, and you can share your data like this over the web interface, and I tried that. I like that, but I just don't have a use case for my home lab. What else we have? So other interesting things I think is this one, which I think to use. So you can share your disk drives over the Storg service and get paid for that. And by installing the application on the barebone Linux server, it's a bit more harder than just set up and install it on the trueNAS server. So I'm thinking about that service to install it in my server room, which I know now I'm preparing, and I think I will make another video I'm preparing my server room in a basement, and I think the first service which will run there, that will be a drive space share via the storage service. Yeah, and I am planning to have some passive income from that. Alright, so applications is really amazing topic, and I think you can get a lot of use from that if you, for example, have home automation. I have some home automation here, but it's based mostly on Apple services, and it's not very extensive. It's only the lighting, the turning on and off lighting automatically. So I don't need home assistant here because I actually also don't see a lot of use cases for home automation at my home, but it's very useful, I think, for a lot of homes. You can have FTP server by using the applications. Yeah, you can have Minecraft server here. Also, it's easy to run it as a Docker container because everything is almost prepared. Of course, you can share your disk drives, and there are more applications here. Oh, of course, I want to mention there is a Pi-hole, which you can run as a Docker component container also, and filter ads in your home Ethernet. I have it. It's running on my Raspberry Pi, so I also doesn't run it here. But if you don't have a Raspberry Pi server, you can run it here. But yes, my idea is to have more separate hardware devices, and when one comes down, all the network other services are working. So that's for hardware redundancy. Yeah, so that's more or less about the application. So as you can see, trueNAS server can have virtual machines, can have Docker containers running on it, and almost the last thing is the logs in the form of graphs. So you can see reports on the CPU usage. As you can see, my CPU is not used a lot. It's more than enough to have this 4 cores Xeon CPU. Its temperature mean are about 30 degrees, so usually it's almost cold. And my load is pretty low, as you can see, up to 2% on average. But there is more interesting information here, so let's go through the disks. So as you can see, this SDD disk, it has constant input, constant writes. This is the system disks and system writes log state. So, and you can see that from this graph. If you go to the data drives, so as you can see, my data drive had some data written on it recently. I think that was a backup. Then and it was mirrored, that data, and you can see there was some reads from my media drive here. Alright, and below you can see also the graphs of my drive's temperature. You can see that it's almost all the time stable, and yes, SSD disk is a bit colder than hard drives, but still the temperature is really not high and really good. Next thing, you can see the memory utilization. So at the moment you can see how much free RAM is here, how is used, how much of used RAM, how much of cached one, and you see that these trends over the time. The next thing you could see, yeah, and as you see, I don't use swap, I use RAM. RAM as a swap because it's faster and it doesn't eats up the disk resources. Okay, so we also could see a network utilization. So as you can see, there was writes on the disks, and this data was received over Ethernet, and there also was reads from the disks, and that data was sent over the Ethernet. So that's also pretty neat historical graph of the network usage. There is additional data graph for the system uptime. So I just started a server today in the morning, so it's uptime just a few hours now when I'm filming this video. And there is additional information about the file system, and actually what's interesting here, so ZFS file system, it tries to cache the data to the RAM, and on these graphs you see how successful the useful data was found in the cache by not using the slow disks but using the cache. And successful hits, that you can see almost all the hits, so all the hits were successful. So when you use some files repeatedly, they go into the cache, and when you work with a RAM, and RAM is automatically synced with a trial, so it's using transactions, ZFS use transactions, so it's completely safe and it's very fast. So this is why I like ZFS file system very much. Yeah, you can see the swap file size, how much data was demanded, how prefetch data how much of prefetch that data was missed. So, but mostly these two graphs are most informative for me, and I see that I have enough of RAM now, and more RAM is coming. So I will have 64 gigabytes. On previous testing system, I saw that they also could be used. It's not it's not too big. 64 gigabytes cache is also could be used in my use case. But even with 32 gigabytes of RAM, I have a lot of successful cache hits, and I'm happy with that. So that's all on the reporting, and the last thing is the setup menu of the system. So you can press an update button here, and to see if you have the latest operating system of trueNAS. You can install manual updates. It's usually not recommended, but there are some cases to do that. The general overview is the processor you have, memory you have. You can configure your graphical user interface here. For example, you can change the theme to a different color. There are more configurations here. I didn't done anything here, there is no use for me. Of course, you can change the time zone. This is very important. I changed that. You can set up an email here, email server here, and receive the notifications from the server to your email box. I didn't change NTP servers, nothing changed here. In this advanced configuration screen, let's come back. I forget to mention one thing. There is a button Manage Configuration. So here, when you press download file, you save the trueNAS configuration to the separate file. And what is interesting here, that when you can install a new version, it's pretty easy. It's just a few steps and you install it. empty new trueNAS installment, you can do that, and then just upload the configuration and your system is ready. So it's really easy to migrate to our system, to change the system drive. For example, if system drive crashes, you just put a new drive, install the initial system with initial configuration, upload the configuration, and it works. And data drives were doesn't relate it to the operating system at all. So you install operating system, upload configuration, and it sees your drives in the system. And that's amazing. That's amazing how easily you can restore the working system. So this is a very important thing. I do manual backups here, but the system saves this file every night around 3 o'clock at night to the system disk also. Yeah. So let's go further in the advanced configuration. The two important things are here that you can run some commands on the startup, so on the init or shutdown, and you can set up to run some commands periodically as a cron jobs. So what I have on a startup and what I run periodically. So one thing what I do, I set up higher cache for ZFS file system. When it's set it up by default, ZFS file system uses only half of the RAM for caching. I'm using most of it here, 30 gigabytes from 32, and it works perfectly. And other thing, I trim my boot pool SSD drive every time my system starts up for the faster responsiveness of that drive. So this is also two nice features, automatic commands on the disk startup. Other thing I changed here, but that's only for my home task, for my home setup, is I changed the session token lifetime. That means that when I log into the system, I leave the monitor on and I see the screen all the time. The screen is on all the time because default token time is 5 minutes. So after 5 minutes, this monitor will log out, and when I go through my screen next time, I need to log in to see how my system is going, and I changed it to 12 hours, so you can have this monitor all the day on. Of course, it's only in the secure environment, like in my home, but I just go through my room and just take a glance on my screen and see that everything is perfect. So I changed the session time here. And I saw in the user forums, that a lot of users demanded for that, so trueNAS included a possibility to change token lifetime. And that's all I changed here in the advanced configuration. Yeah, boot pool is by definition was separated. That was the decision by IX Systems in the trueNAS implementation. Just to don't do anything with boot pool, you are working with data pools here, and boot pool management is more advanced, and it is done here. In the boot tab, in the system configuration, so you can see some stats of your boot here, boot pool here. Of course, it has automatical scrub tasks for data integrity every 7 days. Additional information, it's the layout on the file system. So where is my boot drive on the file system, and you can manually scrub the boot pool. Yes, and that's more or less all the information. which is about the boot pool, and you can do a script task here, you can automate a script task here. Trims of boot pool are made in the data protection part, SDD is a boot pool, and smart tests of a boot pool are made in the data protection screen, and trim task is made here on the advanced system configuration screen. Yes, of course, not all these things are in the same place, but that's because the boot pool is separated intentionally. What else we can have here? We can have the list of the services which run on my server now. So it's files sharing service, SMB, and it's automatic disk checking service, S.M.A.R.T. I will have a separate video on SMB service, in particular on one advanced server. Advanced setting is multi-channel. What's interesting about multi-channel, I already mentioned, when you have multi-interface Ethernet card, you can aggregate these ports, and the speed multiplicates. If you, for example, have 4 1 gigabit ports by using Samba multi-channel, I will have a separate video on that, how to configure that, and I will show how it works. You can speed up this data transfer much more by utilizing your free interfaces of Ethernet card. The important thing is here that you need to have on the client and on the server the same amount of physical Ethernet ports. So this is not very nice for Mac Studio, because it has only one internal 10 gigabits Ethernet port, and then you need a few external USB Ethernet cards to have like separate physical data line connections between the server and the client. And only in this situation on Mac OS multi-channel could utilize additional interfaces. So that's a drawback, but still in some cases it works pretty well. So that will be additional topic on other videos. Alright, and another screen what we have is a shell. So from time to time, for example, you want to see the status of your Z pool here, and it's additional information. Maybe you don't need that, but sometimes it could be additional important information. What else you can see here? So you can see S.M.A.R.T information, for example, for my SDD drive, boot pool drive. Other information, other things you can do. So, for example, you can look how much of disk space is left on boot pool. So I can see that 897 gigabytes of data of free space is on my boot pool. By the S.M.A.R.T tools, of course, you can see how much of lifetime is left for your SDD, from your flash drive is left. So as you can see, my drive is pretty new and a lot of resources. We still have a lot of resources. So this is some of the use cases for the console, but as I mentioned, trueNAS works on, it's created on the Debian Linux base, so most of the Linux commands work here, and trueNAS also and ZFS file system has its own commands, so all of your commands which are not covered, which are advanced and not covered by the graphical user interface could be run here. And the last thing is alerting settings, and I think I didn't done anything here. So yeah, so that's all, folks. I wanted to show you. So that's a brief overview about the trueNAS operating system, which I'm using for my home lab, for my safely storing of my files, for sharing the media over my Ethernet. Yeah, and as you saw, there was a lot of interesting topics during this overview presentation. So I will be going through that on the further videos. And this time I think there was more than enough information about the trueNAS. It's pretty good introduction to the system. So that's it for this time. Thank you very much for spending your time with me. I hope this video was helpful. All your comments are welcome. Please write them below the video. And till the next time, see you. Goodbye.